Hello viewers, welcome back to Programming Learners 3.142. So in this video, we are going to write a C program to convert temperature from one unit to other unit. Let us start writing it. So first we'll comment the purpose of this program, and that is C program to convert temperature from one scale to another scale. Okay, as it is a multi-line comment, we can extend the comment to the next line, and here we will write written by Programming Learners 3.142. Okay, so comments are the text which the compiler will going to ignore. These text are for only for uh, programmer's reference. That means it is a note for the programmer. Now we will include the header file, and syntax for that is hash include the header file name stdio.h. Okay, now we will write the main function int main. Here the int signifies the return type of main function is integer. Okay, int main. Now we need some variable to store the temperature value and unit of the temperature that user has entered. Also we need another variable to store the final temperature value and final unit of temperature. So for that, to store the unit, we need a two characters variable, and syntax for that is character I temp unit. I temp unit means initial temperature unit, and app temp unit final temperature unit. Okay, now to store the value of temperature, we need double variable. Syntax for that is double I temp value and f temp. Okay, now apart from these four variable, we need another four integer variable to store the lower limit of temperature and upper limit of temperature in initial temperature unit or initial temperature scale and in final temperature scale. So for that we will define int LLIS, lower limit of initial temperature scale, LLITS, then upper limit of initial temperature scale, ULITS, then LLFTS, lower limit of final temperature scale, and ULFTS, upper limit of final temperature scale. Okay, so these names are quite confusing, so we write a comment here. LLITS, this stands for lower limit of initial temperature scale. Okay, ULITS, this stands for upper limit of initial temperature scale. Okay, now let the comment be multi-line comment. So instead of this, we will write this. Okay, Now here ULITS stands for upper limit of initial temperature scale. Similarly, LLFTS stands for lower limit of final temperature scale. And ULFTS stands for upper limit of final temperature scale. Okay, let's end the comment here. So after declaring all the variable, now we will prompt the user to enter the value of temperature. Before that, we will provide a heading on the output screen. Okay, so heading will be printf /n/t/n is the escape sequence to create a new line, and /t is the escape sequence to create a tab character on the output screen. Let the heading will be in the capital letter or uppercase letter. The heading will be temperature conversion. Okay, from one unit to other unit. Okay, so this will create an heading on the top portion of the screen. Now let us put a continuous line throughout the width of the screen, and for that we'll use a for loop. uh, so before printing the continuous line, we need to use an escape sequence /n. Okay, so that cursor will move to the new line in the output screen, printf/n. Now we will use a for loop for int I equal to 0, and syntax for loop is first initial value of the counter variable, then condition I less than or equal to 255, then semicolon I plus plus, the increment. Printf percentage C is the format specifier for character, and the character value is 196. This will create a continuous line throughout the width of the output screen, and we are using a single statement in the for loop, so no need to put a curly bracket. And here in this part in line 15, this declaration is called declaring counter variable on the scope of only for loop. That means this integer variable I is visible only within the for loop, and it is not visible outside of the for loop. Okay, this will prevent any kind of error. Now that we have printed heading and a continuous line on the output screen, now we will ask the user to input the initial temperature and initial temperature unit. For that we will use printf/n For Celsius, enter dash capital C. Okay, then slash n. Actually, let us use slash n slash t. For Celsius, enter capital C. Then for Kelvin, enter capital K or uppercase K. Then again slash n slash t. For Fahrenheit, enter capital F, again slash n slash t. For Reamer, enter dash capital R. Okay, so before this, we need to print another message. Select initial temperature scale. Okay, select initial temperature scale. Now we will put a semicolon here. Return 0. Let us first check this program, how the output screen is getting generated. Okay, so for that we need to save this program. Control S. The name of the source file is temperature conversion from, or we can write temperature conversion convert. Okay, temperature convert. Now we'll choose the type of file as C source file. Save. Now I will press F9 key to compile this program. So it is saying error 0, warning 0, all good. Now I will press F10 button. Okay, so temperature conversion from one unit to other unit. It is printing a very large continuous line. Select initial temperature scale. All good, but we have to reduce the length of our line. So let's say 155. I will combine it again. I will run it again. Okay, now all good. But we need to align this C, K, F and R. So for that, we need to move C 3 space, I think, towards right, K 4 space and R 3 space. Okay, so that will be very attractive to see. C 3 space, K 4 space and R 3 space. Control S. We will compile it again and we will run it again. Now it looks very good. So we will write the next part of code. Select initial temperature scale. Now we need to verify that user has entered the correct character, and for that we will use an if statement. Here if first we need to store the input character to the variable itemp unit. Okay, so we will use a command scanf, or a function, actually it is a function, scanf percentage %c ampersand I temp unit. So whatever the user has entered, store that to the address of variable itemp unit. Okay, now if itemp unit equal to capital C, or the symbol for OR operation is two vertical lines, itemp unit equal to capital K, as this is an character variable, we need to include that within a single quote, or itemp unit equal to capital F, or itemp unit initial temperature unit equal to no double, it is single quote, capital R. So this should be our input values for initial temperature unit. Okay, so if user has entered this unit, then there is no problem. And if user has entered any other character apart from these characters, so we need to display a message. Okay, so for that I will use another parenthesis here. And here I will write not symbol. Okay, so if user has entered any character which is not C, or not K, or not F, or not R, in that case this if condition will be executed, and the if block is, if input character is none of these, then printf will display message /n/t invalid choice, invalid entry. Okay, and we'll write try again. Okay, so after this statement we need to let the user to select the initial temperature unit again, and for that we will use the go to statement. Go to invalid initial temperature unit. Okay, so here we are creating a label invalid initial temperature unit, or you can shorten this label invalid initial temperature invalid initial temperature unit. Okay, so for that we need to create a label here invalid initial temperature unit, and the syntax for creating label, simply write the name or identifier and put a colon, not semicolon, colon. So whenever user will enter anything which is not C, K, F or R, it will print invalid entry, try again, and it will ask the user to select the initial temperature unit again. Okay, so but we don't need to print the symbols here, so we will use this level at this position at line 19. Okay, so let us test this. So for that I will save the program, F9 to compile it, zero error, zero warnings. Then I will use F10 to run this. Okay, select initial temperature scale. Let's say I will enter C, capital C, uppercase C, enter. So there is no problem. Now if I enter something which is not in the list, let's say I will enter capital Q, it will say invalid entry, try again, and it is printing this message twice. Okay, so for that we need to use another function for getting input. It is printing now 3 eyes. Okay, let's enter key. Now program is successfully terminated. To resolve this problem, let us use another function to get the input from the user, and that function is, instead of the scanf, here I will write f plus stdin, that means plus the standard input buffer, whatever the standard input characters stored in buffer, just erase those things. Okay, now I will use another function to get the input, and that is I temp unit equal to GETCHR, get car. Okay, now I think this should solve our problem. Here I will use this to enhance the output screen, look of the output screen. Here also I will use this to enhance the look of the output screen. Now I will save it, compile it again, and run it. So now it is looking much better. Let's I enter lowercase c. It is saying invalid entry, try again, because lowercase c is not a valid input unit. So let us enter capital T. Again the same thing, capital T is not a valid input unit. So let us enter F, capital F, uppercase F. It is a valid input unit. So there is no problem. So everything looks good. Now I will prompt the user to enter initial temperature value. Printf /n for new line /t for new tab character. Enter initial temperature value. Okay, now whatever the user will enter, we need to store that into the variable itemp value. Okay, so for that I will use, and itemp value is a double type of variable. So for that I will use scanf statement, scanf function, scanf percentage lf. Percentage lf is the format specifier for double variable. Percentage lf ampersand I temp value, initial temperature value. So whatever the value user has entered through the keyboard, store that to the address of variable initial temperature value. Okay, now it is time to prompt the user to select the final temperature unit. Again I will use the printf function, printf /n/t, enter final temperature unit. Final temperature unit, or a final temperature scale. As earlier we have used the word scale. Okay, again we will store that to the variable. For that we will use f plus stdin, and we will store this to the variable f temp unit, f final temperature unit, equal to get character. GETCHR is a standard function available in the header file get char. Okay, now we need to check for whether the user has entered the correct character or not. So again we will use this statement. If the entered character is not any of these, then printf invalid entry, try again. Okay, so here you can redirect it to the another level, invalid I final FIN. Okay, invalid final temperature unit. Or else if f final temperature unit equal to initial temperature unit, as the if the initial temperature unit and final temperature unit is same, then there is no need of any conversion. So we will check for this condition also. If final temperature unit is equal to initial temperature unit, then printf the message initial temperature unit and final temperature unit cannot be same. Okay, try again. We need to capitalize this string. Try again. Okay, in this case also we'll go to the level invalid final temp unit, and we'll create that level here. Okay, so if user will enter anything which is not C, K, F and R, then it will display this message and will again ask the user to input the unit, final temperature unit. And if user will enter the same temperature unit, it will display this message and again it will ask the user to input another temperature unit. So let us test this. Okay, where we will use go to statement. Go to the statement. Okay, I will compile this again. Control S, F9, F10. I will run it. So first I will choose initial temperature unit. Let's say I will choose Celsius. Then it is asking for a temperature value. Let's say I choose 25 degrees centigrade. Now it is asking for final temperature scale. Let's say I want to convert 25 degrees Celsius to Fahrenheit scale. So for that I will choose F. Everything working fine. Let us run again. Let's say I will choose same centigrade. Initial temperature value 25 degrees centigrade. I will choose again the centigrade as final temperature unit. Let's see how it will react. It says initial temperature unit and final temperature unit cannot be same. Try again. Let us now, this time I will enter F, then it work properly. Okay, it will enhance the look. Now the actual conversion start. As user will has entered the initial temperature unit, user has entered the final temperature unit, and user has entered the initial temperature value. So how we will convert the temperature? Okay, Let us first uh, see the formula to convert the temperature. So for that I will use a slide. So how we convert temperature? Here I will write temperature conversion. So to convert temperature, we need to remember two temperature value on each scale, that is melting point of ice and boiling point of water. Boiling point of water, the temperature at which the liquid water will start converting into steam. And another temperature is melting point of ice, the temperature at which the solid ice start melting and start converting to liquid water. Here in Celsius scale, it is 100 degree centigrade and it is 0 degree centigrade. Okay, in Fahrenheit scale, the melting point of ice is 32 degree Fahrenheit and boiling point of water is 212 degree Fahrenheit. Similarly, in Kelvin scale, the melting point of ice is 273.15 Kelvin and boiling point of water is 373.15 Kelvin. Here mark this, there is no degree symbol in Kelvin scale. Okay, and in Reaumur scale, the melting point of ice is 0 degree Reaumur and the boiling point of water is 80 degree Reaumur. Okay, so to convert temperature from one scale to another scale, we will use a formula. Temperature value in scale 1 minus lower limit of scale 1 divided by upper limit of scale 1 minus lower limit of scale 1. This is equal to temperature value in scale 2 minus lower limit of scale 2 divided by upper limit of scale 2 minus lower limit of scale 2. So we will use this formula. So here temperature value in scale 2 So let us, the initial scale is Celsius and the final scale is Fahrenheit. So for this, temperature value in scale 1, let's say it is x degrees centigrade, okay, minus lower limit of scale 1, it is 0, divided by upper limit of scale 1, this is 100, and lower limit of scale 1, this is 0. This is equal to temperature value in scale 2, let's say it is F, okay, F minus lower limit of scale 2 is 32, this value, and upper limit of scale 2 is 212, this value, minus lower limit of scale 2, okay. So in this way we are going to convert the temperature. So temperature value in scale 2, temperature value in scale 2 is equal to upper limit of scale 2 minus lower limit of scale 2 whole multiply by temperature value in scale 1 minus lower limit of scale 1 divided by upper limit of scale 1 minus lower limit of scale 1 plus lower limit of scale 2, okay. So this will be our formula. So in terms of our variables, here we have declared the variable as LLITS, ULITS, LLFTS, ULFTS, and initial temperature value is I temp value, final temperature value is F temp value, okay. So in terms of our variable, the final formula will be F temp value is equal to L temp value equal to lower limit of scale 2, sorry, upper limit of scale 2, that means U L F T S, upper limit of final temperature scale, minus lower limit of final temperature scale whole into temperature value in scale 1, that is I temp value, initial temperature value, minus lower limit of initial temperature scale LLITS divided by upper limit of initial temperature scale minus lower limit of initial temperature scale plus lower limit of final temperature scale. So in terms of variable, we have declared the final formula will be like this. This is our final formula. Okay. So let us write the code. Let us write the code. So before converting the temperature, we need to define the upper limit and lower limit of initial temperature scale and final temperature scale. Okay. So for that we will use if statement. Here if initial temperature unit equal to C and final temperature unit equal to K. Here also we have missed a single quote. So in this case, set the LLITS low limit of initial temperature scale equal to 0. Okay, let's say 0.0. Okay, instead of declaring these as integer, let us declare this as float variable. Okay, or double variable, because it will not create any problem in type conversion. Okay, so let us write lower limit initial temperature scale is 0.0. Similarly, upper limit of initial temperature scale is 100. Again, lower limit of final temperature scale is for Kelvin, it is 273.15. Okay, and upper limit of final temperature scale for Kelvin scale is 373.15. Okay, or there can be, if initial temperature unit is Kelvin and final temperature unit is Celsius, so we will just have to reverse it. Lower limit of final temperature scale is 0, upper limit of final temperature scale is 100, Lower limit of initial temperature scale is 273.15. Upper limit of initial temperature scale is 373.15. Okay, so Celsius to Kelvin is over. Now we'll look at Celsius to Fahrenheit. Here we'll use the statement else if. Else if. Okay, let us copy this statement. Else if initial temperature unit is degree centigrade and final temperature unit, let's say Fahrenheit. Fahrenheit. So lower limit of initial temperature 0.0, upper limit of initial temperature scale 100.0, lower limit of final temperature scale is 32, upper limit of final temperature scale is 212. Okay, and let's say initial temperature unit is Fahrenheit and user want to convert it to the Celsius. So in this case, we will reverse the limits. Let's say this is the Fahrenheit and this is Celsius. For this case, we will reverse the limit. Lower limit for final temperature scale is 0, upper limit for final temperature scale is 100, lower limit for initial temperature scale is 32, and upper limit for initial temperature scale is 212. Now let us look at Celsius to Reaumur. Okay, in this case, lower limit remains the same. Upper limit of final temperature scale, lower limit of final temperature scale is 0. Let us make it decimal. And final is 80.0. Okay, now let us reverse the situation. User has entered initial temperature scale as Reaumur and he want to convert it into Celsius. Else if initial temperature unit is Reaumur and user want to convert it into Celsius. So in this case, we will just reverse the limits. Okay, so lower limit of final temperature scale is 0, upper limit of final temperature scale is 100, lower limit of initial temperature scale is okay, F to C, C to F is done, R to C. Lower limit of initial temperature scale is 0.0, upper limit of initial temperature scale is 80.0. Then C to R. Okay, C to K, K to C, C to F, F to C, C to R, and then R to C. Here the limits will be 0.0 and this will be 80.0. Okay, now we'll take another case, that is Kelvin to Fahrenheit and Kelvin to Reamer. So let us copy it, Control C. So user has entered initial scale as Kelvin and user want to convert it to the Fahrenheit. So lower limit of initial temperature scale is 273.15 and upper limit of initial temperature scale is 373.15. Lower limit of final temperature scale is 32.0 and upper limit of final temperature scale is 212.0. Now let us take the reverse situation, that is user has entered initial scale as Fahrenheit and user want to convert it into Kelvin. In this case, let us copy this code and this is Fahrenheit and user want to convert it into Kelvin. So in this case, we will just reverse the unit limits. So lower limit of final temperature scale is 273.15. Upper limit of final temperature scale is 373.15. Lower limit of initial temperature scale is 32. Upper limit of initial temperature scale is 212.0. Now let us take another situation when user has entered the temperature in Kelvin and user want to convert it into Reamer. So for this, cell temperature unit is Kelvin and user want to convert it into Reamer. Okay, so in this case, low limit of initial temperature scale will be 273.15 and upper limit of initial temperature scale is 373.15 and lower limit of final temperature scale is 0.0 and upper limit of final temperature scale is 80.0 into Fahrenheit, Fahrenheit to Kelvin, Kelvin to Reamer, then Reamer to Kelvin. Now let us take another situation where user has entered the temperature value in Reamer and user want to convert it into Kelvin. So in this case, we'll just have to reverse the limit. Okay, initial is 0, upper limit of initial temperature scale is 80. Now let us look at another situation where user has entered the temperature in Fahrenheit and user want to convert it into Reamer. So for that, let us copy this. User has entered the temperature in Fahrenheit. User want to convert this into Reamer. So for that, lower limit of initial temperature scale will be 32.0 and upper limit of initial temperature scale will be 212.0. Similarly, lower limit of final temperature scale will be 0 and upper limit of final temperature scale will be 80. Okay, now take the reverse situation where user has entered the temperature value in Reamer and user want to convert it into Fahrenheit. Okay, so in that case we need to just reverse the limits. Okay, so that should be it. 12 cases: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we have exhausted all possible entries of initial scale and final scale. Okay, so let us now convert this, and for conversion we have uh, written the formula: final temperature value is equal to the upper limit of final temperature scale minus lower limit of final temperature scale whole into temp initial temperature value minus lower limit of initial temperature scale divided by upper limit of initial temperature scale minus lower limit of initial temperature scale plus lower limit of final temperature scale. Okay, now we have successfully converted the temperature and we need to display this to the output screen. So for that we will use printf within double quotes slash and slash t, and format specifier for double type is lf percentage lf. Then for degree symbol we'll use a percentage c equal to percentage lf and percentage c. Okay, and we will use another percentage c for unit, for printing unit. Here also we'll use another percentage c for unit. So let us specify what does this percentage lf will display. The first percentage lf will display initial temperature value. Okay, then the first percentage c will display a degree symbol. So for that the constant is 248. Then second percentage c will display the initial temperature unit. Then second percentage lf will display final temperature value, that is f temp value. and third percentage C will display another degree symbol, and fourth percentage C will display the final temperature unit. Okay, but there is a problem. This statement is only for when input unit is not Kelvin or output unit is not Kelvin. Okay, so here we will use if I temp unit is not Kelvin and F temp unit is also not Kelvin. Then we'll print the output in this format. But if else if initial temperature unit is Kelvin, then we'll print, because the Kelvin do not require a degree symbol. Okay, so we'll print slightly modified version of this statement. iTemp unit does not need a degree symbol, so we'll erase this percentage C and also we'll erase this. Okay, or there is another chance, else if ftemp unit is equal to capital K, then we will use this statement, modified version of the statement, control C, control V. Here degree symbol is not required in final temperature unit, so for that we'll erase this. Okay, so this completes our program. Let us save it, control S, and I hope everything is okay. Let us compile it. Okay, it compiled successfully, and let us run it. So it is asking to select the initial temperature scale. Let's say initial temperature scale is Celsius. For that, C initial temperature value, let us it is 25 degrees centigrade. Okay, enter final temperature scale. Let's say final temperature value, I want it in Fahrenheit. Okay, so it is saying 25 degrees centigrade equal to 77 degree Fahrenheit. So all looks good apart from these extra zero. Okay, so let us modify it. Here we will use a width specifier 0.2. That means it will display 2 digits after decimal place. Here also I will write 0.2. Okay, 0.2. Here also I will write 0.2. Here also I will write 0.2. Here also I will write 0.2. Control S. Let us compile it, then run it again. Initial temperature scale is Celsius. Final temperature scale is, let's say, Fahrenheit. Okay, 0 degree centigrade equal to 32 degree Fahrenheit. As we entered a wrong input for initial temperature value, so whatever the garbage value of double variable that got displayed. So let us run it again. Initial temperature unit is Celsius. Initial temperature value is 25 degrees Celsius, and we want to convert this into Fahrenheit. So it is saying 25 degrees centigrade equal to 77 degree Fahrenheit. All okay. Now let us run it again and try to give Kelvin. Initial temperature scale is, let's say, Celsius. Initial temperature value, let's say, 0 degree Celsius. Final temperature scale is Kelvin. So 0 degree Celsius equal to 273.15 Kelvin. All looks good. Okay. Now there is one problem, or not a problem. Actually, we suppose we want to give flexibility to user to enter either uppercase C or lowercase c, uppercase K or lowercase k. In that case, we will convert the character into uppercase. Whatever the user will enter, we will convert that into uppercase. Or if it is already uppercase, we don't change it. Okay. So for that, we will have to declare a function to convert the character into uppercase. Okay. So let us write a function. Return type of the function is a character. So first here we will declare the prototype of the function, and the prototype we first have to specify the return type, that is character. It will return and character data type, and then we'll give the function name. Function name is lcase to ucase. Okay, that means lowercase to uppercase. Okay, and this function will take in character as input. So we have successfully declared the prototype of the function. Let us define the function here. Character here, lcase to ucase, lowercase to uppercase, and here we will have to give the name of the variable. Let's say ch for character. Okay, so if the character is an lowercase character, then convert it to the uppercase, otherwise do not change it. Okay, so for that we'll check the lowercase character starts from the value 97 and goes up to 122. So if ch greater than equal to 97 and ch less than equal to 122, then ch equal to ch minus, as uppercase character starts from 65 and goes up to 90. Okay, so difference between 65 and 97 is 32. So we need to subtract 32 here. Then return ch. Okay, here if this condition is met, that means entered character is a lowercase character, then it will convert it into the uppercase character. Otherwise, it will do nothing with the character. It will simply return the character, whatever the character given to it as input. Okay, so This completes our function L case to U case. Then we need to invoke this function, or we need to call this function. So here I will say itemp value, itemp unit equal to L case to U case L case to U case item value. L case to U case. L case to U case. Okay, all okay. Similarly, here I'll say f not value, actually it is unit, itemp unit. Here also f temp unit equal to L case to U case f temp final temperature unit. Okay, now this will solve our problem. That means it will provide flexibility to the user to enter either lowercase c or capital case C, lowercase character or uppercase character. Okay, I think everything is right. Let's save this program and let us execute it and let us run it. Select initial temperature scale, let's say C. Okay, enter initial temperature value 25, let's say, and I want to convert it into Kelvin. Let's enter lowercase k. So it is converted to uppercase. Here we can see 25 degrees Celsius equal to 298.15 Kelvin. So this completes our program. I hope I have explained everything clearly, and thank you for watching. See you in the next video.